All right. Starting off front and center, we have taste. And we're going to start off talking about salt and sour receptors. So, on these receptors of the tongue, these cells have exposed receptors on the tips. And for salt and sour, we're going to have sodium for salt. And let me change my colors. Sodium for salt and hydrogen for sour. And so what are those going to do? As soon as sodium enters into the cell, it's going to do a Buang. We're going to Buang way downtown. And what that's going to do is that depolarization is going to activate the calcium voltage gated channels. Calcium, we know, is known for activating the neurotransmitter. I don't believe there's a specific neurotransmitter for taste. I could be wrong. Anyways, that neurotransmitter is released. Snare proteins pull it in, open up, let them out, and then action potentials sit straight to the brain. Okay? So there's only a slight difference with the hydrogen for sour taste. So we eat a Sour Patch Kid, we think it's sour, we send a Buang down, and what that's going to do is, hold on a second, let me think. It's on the tip of my tongue. So the difference with the hydrogen is that it's going to inhibit this voltage gated potassium channel. Whereas or I guess this is a leak channel, but with sodium, that potassium channel is going to be open and leaking out potassium. In the case of sour, it's going to inhibit this channel, which causes further depolarization. I guess that just makes it easier for us to make it downtown, stimulate the voltage gated calcium channel, which then stimulates the glutamate and snare proteins, bring it down, sending action potentials down the ganglia into the brain. Okay. So next we have sweet, umami, and bitter. This is my favorite word. So what's going to happen here is this is all going to be the same. It's not going to be like the hydrogen and sodium where it's different. No. Here we're working with just a ligand, so I'm going to do it in dark blue so it's easier for you to see. So the ligand is going to bind to the GPRC, which will then activate phospholipase C, and that is going to bring in IP3, which is responsible for stimulating the RYR channel, which then lets out calcium. Calcium is going to stimulate the the neurotransmitter, which will then send action potentials down the ganglia to the brain. And I think I got that mechanism down right. Now we have smell. And with smell, what we have is mucus in our noses. If we've ever had a runny nose, we all know this. And the epithelium will make mucus, which will trap chemicals that we smell up our sniffer. And so here I have zoomed up what's going to happen for this mechanism. So here we have, this is adenylyl cyclase, and what's going to happen is a ligand will bind to this unit, which will then stimulate adenylyl cyclase, which then activates the cAMP, and that's going to let in the sodium and potassium channel. Chloride will leave the cell, and that Buang will be sent up through the neuron to the olfactory bulb, which will then send action potentials to the brain. one little thing I forgot to add. So on these dendritic cells at the very bottom, this is a GPCR unit, just similar to what we had with sweet umami and bitter. And so the GPCR will have a chemical bind as a ligand, which will then activate the alpha unit, increases more CAMP, which then opens up the sodium potassium channel, causing that BONG to go all the way up to the olfactory bulb, and then that will go sending action potentials to the mothership.